Hello everyone, this is Isha Kumari from Sri Venkateshwara College of Engineering, Bangalore, from the Department of Computer Science and Artificial Intelligence, and here is a presentation on data science and its applications. So the topic for today is the normal distribution. So the introduction to normal distribution. Definition. The normal distribution is a continuous probability distribution that is symmetric about the mean, depicting the distribution of a set of data. It is also known as Gaussian distribution. So normal distribution is basically a continuous probability distribution, and it is also symmetric about the mean, and it has a set of data. So the importance of normal distribution is that it is widely used in statistics, natural and social sciences to represent real valued random variables whose distributions are not known. So the next is historical background of normal distribution. So Carl Friedrich Gauss developed the Gaussian distribution in 1809 while studying astronomical data. So normal distribution was developed by Carl Friedrich Gauss. Then Abraham de Moivre. Earlier contributions in 1733 with the central limit theorem, which forms the basis for the normal distribution. So the next is properties of the normal distribution. Shape. Symmetrical bell curve, mean, mu, median and mode are all equal. So the shape is symmetrical and bell curved. It has mean, median and mode which are all equal. Then coming to parameters, mean, mu, the center of the distribution, standard deviation rho, measures the spread of the distribution. So there are two parameters in normal distribution, which is basically the mean and the standard deviation. So probability density function PDF, which is a function of fx equal to the given formula which is shown here. So this is the probability density function. This is the formula used in normal distribution. So the next is empirical rule. So 68, 95, 99.7 rule, which is 68% of data within one standard deviation of the mean, then 95% within two deviation, then 99.7% within three deviations. So 98, 95 and 99.7 rule is followed in the empirical rule, which is given below. Then what is the significance of this empirical rule? So basically empirical rule helps in understanding the spread of data in a normal distribution. Next is a standard normal distribution. So what is standard normal distribution? Basically it is a special case of the normal distribution where the mean is 0 and the standard deviation is 1. Standardization. Convert normal random variable x to standard normal variable z using z equals to x minus mu by rho. So this is the formula. I'll give you 1 second to just look at this formula. So next, uses. So what is the use of the standard normal distribution? It simplifies calculation of probabilities and comparison of different normal distributions. So basically it compares different normal distribution and the calculation is simplified of the probabilities. Next is applications of the normal distribution. So as we read in the first slide that it is used in statistics. So inferential statistics, hypothesis testing, confidence intervals. So it is also used for hypothesis testing. And natural and social sciences, if we come to the application of normal distribution in natural and social sciences, so It is biological. It has biological measurements, which can be heights, blood pressure. Normal distribution can be used in calculating heights and blood pressure. Then we come to social phenomenon. Examples are test scores, IQ level can be tested using normal distribution. Then finance, stock returns, risk management. It can also be used in finance, and it can be used for stock returns, stock markets, and it can be used to predict the risk, and it can manage the risk. So the next is the central limit theory. The definition for central limit theory is: the CLT states that the sum or average of a large number of independent, identically distributed random variables tend to follow a normal distribution regardless of the original distribution of the variables. And the implications are: justifies the use of normal distribution in any practical situation, basis for many statistical methods. Then the next is limitations of normal distribution. Now limitations have assumptions and alternatives. So assumptions has: real world data may not always be perfectly normal, heavily tails and outliers. So obviously real world data can fluctuate, it can be imperfect, and it is not always perfectly normal. So we can make assumptions based on those data, but it is not sure that we will get a perfect answer for that. Then alternatives: t distribution, squared distribution, etc. for non-normal data. Then again, if we come to the central limit theory, here also we can see that the implications which justify the use of normal distribution in many practical situations, basis for many statistical methods. So we can use normal distribution in many practical situations, such as we have seen already in stock returns, risk management, biological measurements, social phenomenon, and etc. So we saw the limitations, the central limit theory, the applications of the normal distribution, standard normal distribution, and now we come to the conclusion. So in the conclusion, the summary of this whole presentation is that the normal distribution is fundamental in statistics due to its property and the central limit theory. It provides a basis for various statistical methods and practical applications. Future relevance continues to be a critical tool in data analysis, research, and decision making. Thank you.